we will be making use of the West African Examination Council syllabus, and we hope to give an insight explanation to each of the topics listed in this syllabus. It's going to be a long lecture, so take a seat and let's dive into it. The first aspect in this scheme of work that we're going to deal with is number and numeration. In this first aspect, the first topic we are going to be dealing with is called number system or number basis. I'm sure that number system or number basis is not a new topic to most of us. Number system or number basis is the study of numbers with their respective basis. What I mean is that for every number that we are familiar with, 1, 2, 3, and so on and so forth, each of them has their designated basis. And most importantly, if you are dealing with these numbers, if you are using any of the basic operation with these numbers, what I mean is addition, subtraction, multiplication, division, when you are using any of these basic operations to compute these numbers together, don't forget that they are computed, or they must be computed in a particular base. We have different type of bases. We can have base 2, which is popularly called binary. We have base 3, we have base 4, we have base 5, we have base 6, up to base 10. In fact, we have beyond base 10. But based on the scope of this syllabus, the WAEC syllabus, we are going to be restricting our study to base 10, which we call decimal basis. Yeah, in continuation, in nature, we have said that we have different bases. We have different number bases. We can have base 2, which we popularly call binary, and the rest of them. And anytime we are dealing with our basic operation, we said that we must take into cognizance this particular number-based system. But there are some basic rules that you must be aware of anytime you are dealing with computation using any of the bases. The rules are 2. The first rule is that you must not represent that particular base in your computation. What I mean is that if you are computing and you are computing in binary, which is base 2, there is no point in your calculation that you have 2 as part of your answer, because your base 2 is going to have set of numbers that are 0 and 1. If you are dealing with base 3, your base 3 is going to have set of numbers that are 0, 1, 2. So it will always be digits less than that base. That's not the only rule. Then the second rule is that if you are computing using any of the bases, if you must not get a number that represents the base, then you must not get a number beyond the base. In clear terms, it means that if I'm dealing with computation in base 3, I can't get 3, I cannot get 4, and I cannot get 5. Let me give you a practical example from our basic computation in nature. For instance, if you have to add this number together, we have 25 plus 19, for instance. These are our normal addition. This one is 9 plus 5. Ordinarily, it is 14. But it's very wrong for you to write 14 as your answer. It's very wrong. Why? Because this 14 as a digit is more than 10. This base is base 10. The base of our normal natural counting number is base 10. Even if it is not represented, it has an invisible base of base 10. So this 25 is in base 10, this 19 is in base 10. So what do? We write 4. I will tell you how to deal with this when we start dealing with the computation. We write 4 because basically we cannot write the 2 number, the 2 digits, which is 14, because it's greater than the designated base. That's the second rule that we must put into consideration when we are dealing with number system. So moving on, the first aspect of computation that we're going to use on number basis, I will explain the concept of number basis to us, is the conversion from one base to the natural base that we call base 10. I call it natural base because every number in nature has base 10, because base 10 is not always feasible. When you write 25, the base that is hidden in that 25 is base 10, and so on. Now, when you are converting from any of the bases that we know, maybe base 2, maybe base 3, in base 4. As I've told you earlier, based on the scope of WAEC syllabus, West African Examination Council syllabus, we will be restricting ourselves to numbers between base 2 and base 10. So when you are converting from any of those bases to base 10, this is a simple rule. It's just a very direct approach that we use. The conversion from any of those bases to base 10 will be done using what we call expansion. As in, you are expanding, or you are multiplying, or you are expanding a number out. I'm going to give you some set of examples to practicalize that. Follow along. When you have number like 1, 2, 3, number like 1, 2, 3, and this one is given in base 2, and you have to convert it to base 10. You have to convert it to a number in base 10. In this case, if you are converting it to a number in base 10, in this case, I said that the approach of converting this number is to expand. What are we expanding? How do you go about the expansion? If it's an odd number like this that we are given, this is one of the simplest examples that you can come across. If it's an odd number like this, which is 1, 2, 3, base 2, convert it to base 10, then how do we expand? You start giving each of the numbers from the unit number. This 3 is unit, this is 10, this is 100. So from this last digit here, if it is an whole number without decimal, then you start giving this 0, you give this one 1, you give this one 2. Then the approach will go like this, because it is base 10. So we have each of these number, which is this number 1. This is like 100, this is like 10, this is like unit. This number 1 is going to be 1 times the base that we are using, base 2, raised to the power that we have here. Then we bracket it, plus 2, which is this second digit, which is the 10 digit, times the 2, which is this base, raised to power 1, which is the power that we put in. Then plus 3 times the base, which is 2, then raised to the power 0. Then this concept is called expansion. And when we are expanding it, let's go. This is 2, 1 times 2 raised to power 2, this is 4, plus this one is 2 times 2, which is what? 4, plus this one is 3 times 1. Indices, anything raised to power 0 is 1, this is 3. Then we go again, this is 4 plus 4 plus 3. Don't forget to put your equals to, it's very important in mathematics. Then we go again, this is 4 plus 4, 8, plus 3, 11. So this is 11, is either you write base 10 or you just leave it like that. And this gives the first example on conversion of numbers to the natural base, which is base 10. You can write this one as 11 or write it like this, whichever way is correct. So let's give another example to make it more, explicit to us. So we have 3, 2, 1. Still the same approach. Then we also label from 0, 1, 2. We are converting this to base 10 also. Then we go right again. Then that's 3 times, we convert this to base 10, I'm sorry about that. This is base 2, then convert to base 10. So this 3 times 2 raised to power 2, the same thing. The first digit times the base goes to this power, plus 2 times, this is the number 2, times the base, which is 2, goes to this power, then plus, this is the last digit 1, times the base 2, goes to the power 0. Then this is 3, which you are equal to, very important thing to notice. 3 times 2 raised to power 2 is 4, plus 2 times 2, which is also, can still bracket it to avoid confusion, plus 1 times 2 raised to power 0 is 1, according to the law of indices. Then we have, this is 4 times 3 is 12, plus 4, plus 1. And this is 12, plus 4, plus 1. This is 16, and this is what? 17, base 10. I would like to ignore the 10 that I've written here so that I'll give you these two feasible results that you can see. So this is just a basic conversion of numbers in any base. The same approach will be used if the base here is not 2. If it is 7, if it is 8, then this expansion approach is applicable to any of them. We are given the first aspect of conversion from any base to base 10, which is called the natural base. And the first aspect we explain to us, we make use of whole number, like 1, 2, 3 base 2. But there can be some instances that you will be given decimal fraction and you will be expected to convert decimal fraction, which we popularly call decimal numbers. We will be expected to convert this decimal number to, or decimal fraction, to a number in base 10. Let me exemplify that to you. If you are given something like this, 0.123, and this one is in base 3, for instance, and you have to convert it to base 10. Let's make it of this. Now, if you look at this number very well, it is a fractional number. It is really a fractional number, and we call it decimal number, as we normally call it. Now, the place value of whole number is different from the decimal number. When we are giving whole number the other time, we are able to list them, we are able to label them from the last digit at my right hand side, which is going to be unit, 10, and 100. But in this case, this one, after the decimal is going to be tens, this is hundreds, this is with TH, according to the labeling of the place value. So, the labeling of their place value, since it is not labeled the same way we label whole number. So, for us to place our digit, you observe that the first digit here, which is 1, after the decimal point, we don't call it units, we call it tenths. So that means unit is not represented in decimal part. So we are not going to be using 0 at all. In our whole number that we just explained earlier on, we place the last digit, which is unit, we put 0 at the top. But in this case, we are going to have -1, we have -2, we have -3. This represents tenths, this represents hundreds, this represents thousands, and so on and so forth. So let's do this. It's still the same approach, but the only thing that changes is this labeling. This one still remains 0 because this one is before the decimal point. So we go over it like we did. So this is going to be 0 times 3. This base goes to power 0. Plus 1 times 3 is power -1, plus 2 times 3 is power -2, plus 3 times 3 is power -3. So this is the expansion that we are doing. This is going to be 0, obviously. This is going to be 1 times, according to indices, this is 3 raised to power -1. The law of indices, you have to reverse this as a fraction of 1/3. It is indices that deals with this topic, so we can't be deviating. Plus, this is 2 times 1/3 raised to power 2. This one 2 is coming from the explanation given by indices. Then plus 3 times 1/3 raised to power what? 3. Also from explanation of indices. Bracket it. Don't forget, I told you of your equal to. So this is going to be 0 plus 1/3 plus 2/9 plus 3/27. Then of course, you can just deal with this using your normal decimal approach, your normal fraction, the SCM approach if you like. This is going to be 27, of course. Then this is going to be 3 in 27, 9 times 6, 27, so this is 9. Plus, this one is 0, is useless. This one is going to be 3, 3 times 2 is 6, then plus 3. So of course, we have our answer to be 9 plus 6, that's 15. 15 plus 3, that's 18/27. This is correct because this is a rational fraction. I mean, a proper fraction. I mean to say it's a proper fraction. So you can leave your answer like this, or you decide to take it to decimal. if you want it. But this one is in base 10. You can just write 10 here if you feel like. So this is your answer, and this is the way we go about it. Let's give one more example, and we're good to go. This, you can have something like 2.111. Just very simple example, just for us to get our feet, stationed, or we have a clear-cut understanding of this topic. It's going to be 0, it's going to be -1, -2, -3. So we have 2. This one, let's say it is in base 2, for instance, and you are converting to what? Base 10. This 2 times 2 is equal to 0, plus 1 times 2 is equal to -1, plus 1 times 2 is equal to -2, plus 1 times 2 is equal to -3. Then how it will be, this is going to be raised to power 1, 2 is equal to 1, 2 is equal to 0 is 1, indices, plus this 1 times, this one will be explained with the concept of indices, because let me give you a simple explanation here. 2 is equal to -1. According to indices, the negative power make it 1 over, then return the base and return the power of 8. That's a simple explanation I can give. It is only in indices that we can go further than that. Then this 1 times 1 over 2, this is to power 1, so I ignore the 1. Then plus 1 times 1 over 2 squared, then plus 1 times 1 over 2 cubed. That's what we have there. Then we continue by saying that this 2 plus 1, this 2 plus 1 times this is 1 over 2, plus 1 times this is 1 over 2 squared, plus 1 over 2 cubed. Of course, we can also have this to be 2 plus 1 over 2 plus 1 over 4 plus 1 over 8. Then we have the same thing. Find your LCM. You have your LCM. You have your LCM of everything if you feel like. Then we have this place to be 8. Then of course this 8 times 2 is what? 16. Plus this is going to be what? 4. 4 times 1 is 4. Plus this is going to be 2. Then plus this is going to be 1. Then you have 16 plus 4, 20. Then plus 2, that's 22, plus 1, that's 23 all over 8. Of course, you can, this is an improper fraction. You can take this one to a mixed fraction. How many 8 do you see in 23? That's 8 times 2, 16. So 16 minus 23, that's 23 minus 16. Then we have 13, 7, that's 7 all over 8. So that's what we have. You can have 2 equal to between them. So basically, you can see these two examples that give us another, question to be dealt with when you are converting from any of the bases to base 10. But this one is decimal number, or we call it what? Decimal fraction. Any other language we want to call it. So this approach, it's universal. That's one thing about mathematics. Just get the concepts. You can go over it as much as you want. So we continue later. We have come to the end of this lecture finally. Expect more of this kind in our next series. If this lecture has helped you to understand the concept of number system, kindly like and subscribe to my channel for more of this kind. If you have any particular question that you are interested in asking from me, kindly link up with me with my social media platform, which will be put in the description box below. And finally, if you want me to make a video on any of the topics, especially the topic that are covered in West African Examination Council, because we are doing this series in preparation of this exam, you can comment below and I'll pick it up from there. Till we meet again, always remember, ideas rule.